Okay, so properties of integrals. The first one that we have is that if f is defined at x equals a, then the integral from a to a of f of x dx equals, what is that going to be if we take an integral from some number to that same number? It's going to be 0. We had that the other day with our -1 on that graph. So we would get 0 there for that. Oh, shoot. Okay, I think I know what that one was supposed to be. So, if I have f is integrable on AB, then the integral from a to b of f of x dx is going to equal, this property has to do with going backwards, right? So if I switch these limits, so if I go from b to a, such a shame my pen is not working because the integral symbol is my favorite one. It's so pretty. And look at that integral symbol right there. If I switch my limits here, so where I had a to b, now I'm going backwards. I'm going from b to a. Then this f of x dx here stays the same. I'm going to have the opposite sign. That's a negative right there. That's awful. We saw that on that first graph that we looked at whenever our starting point was -1 and we went backwards to -2. We had to use the opposite sign there. Okay. For 3, if f is integrable on the 3 closed intervals determined by a, b, and c, where a is less than b less than c, then the integral from a to b of f of x plus the integral from b to c of f of x. Anybody want to take a guess at what that is? Integral from a to c of f of x dx. And think about what it means. This is the area under the curve from A to B. Then the area under the curve from B to C. Makes sense that if you add those together, that's just all the way from A to C, right? Okay. If you have the integral of 2 functions that are added together, you can break them apart, much like we've done with limits and derivatives and several other things there. So that's going to be the integral from a to b of f of x dx plus the integral from a to b of g of x. That's a property that we've used on a lot of different things that applies to integrals as well. Anybody want to take a guess what we can do if k is a constant right here? You can pull it out front. So it would look like this. You'd have k times the integral from a to b of f of x dx. Okay, and our last one is that if k is a constant, then the integral from a to b of k dx is going to equal, any ideas on this one? It's not just B. That's going to be part of it. Think about what we got here. Okay, we got area under the curve. We got some interval right here from A to B. We've got that our graph is just, oh gosh, hold on. Let me get my line tool. Our graph is just K, whatever K is, right? So if I want the area under the curve, thank you, the area under the curve here. Then what is the width right here? It'd be B minus A. Okay, what's the height? It is K. What would the area of that be? Good. I'm going to write it this way. I'm going to do K times B minus A. B minus A will have to be in parentheses here. So it's just like the length of your interval multiplied by that constant, because it's just going to be a rectangle. Okay, any questions?
I have a question that's kind of unrelated. Why does the dx need to be?
That's a good question to ask. The dx is telling you what variable you are integrating with respect to. So it's a little bit like when we take a derivative and we do dy dx, and it goes on that in the bottom there. We put it there because we were taking the derivative with respect to x. This has to go there on the end because we are integrating with respect to x. Right now, it's just kind of there. We don't do a lot with it. When we get further with integration, it's going to matter a little bit more. So right now, it's kind of just there. It's not part of what you're actually integrating. It's telling you what it is that you are, the variable that you are integrating. So it is also what would let you know that K is not the variable here. Because otherwise, maybe K is the variable in this case. It lets you know that, well, K is just some sort of constant. X is the variable you're integrating. Okay, so here is an example of some of the stuff you will be given for this. You have that the integral from -2 to 8 of whatever function it is that is f of x equals 10. Then from 3 to 8, you get -6. And from 0 to -2, you get -3. Okay? The first question asks us the integral from -2 to 0 of f of x. What would that be? It's going to be +3. And we know that because the integral from 0 to -2 is -3. So if I just switch my limits, it's just going to change the sign of my answer. Okay, then I need 0 to 3. What's that one mean? Or how do we find that one? I've got -2 to 8. I've got 3 to 8. I've got 0 to -2 where I could do -2 to 0. Right there. What's the biggest integral that there is there? Like the biggest range? -2 to 8. So I could kind of break it into pieces, right? What pieces could I break it into? Given what I know. Negative 2 to 0 is 3. So that's part of it. Then 0 to 3, which I don't know, and I know 3 and 3 to 8, right? So this is going to take so much room for me to write with this here. But negative 2 to 8 of f. I'm going to just put an f right here because I can't write very fast. Don't do that. Put f of x dx. But this is going to take me forever. So this would be like the integral from negative 2 to 0 of f plus the integral from 0 to 3 of f plus the integral from 3 to 8 of f. Would you guys agree with that? Okay, we know some of these things. What is the integral from negative 2 to 8? It's 10, so I could replace that with 10. Integral from negative 2 to 0 is 3. Integral from 0 to 3 of f, I don't know. That's what they're asking me for. So I want to leave that there. Gosh, this is bad. And then what's the integral from 3 to 5 of f? Negative 6. So what I'm trying to find is the integral from 0 to 3 of f. That's what I'm looking for, right? What do I need to do to find that? Combine these two right here, and that will give me negative 3. So I will have 10 equals negative 3 plus the integral from 0 to 3 of f. And then what would I need to do, Lucas? Okay, this is just like a variable right here. So you're just adding 3. And
That's what I was thinking.
And you really should be doing f of x dx on all problems. I just am having to write very, very, very slowly. Okay, questions there? Okay, what about the integral from negative 2 to 3?
You can use negative 2 to 0 and 0 to 3.
Negative 2 to 0 and 0 to 3. Put those together, that gives you negative 2 to 3. So that is going to be 13 plus 3, which will give us 16. Okay, here. All right, moving on. This time we know negative 5 to 1. We've got 1 to 5. What is negative 5 to 5 going to be? It's going to be 6. So we'll do 8 plus negative 2. Okay, here's an interesting one. Integral from 1 to 5 of g of x plus 5.
Would it be negative 2 plus 5?
It is not quite. Not quite.
Can't do that.
It is. So when you are doing this, think of breaking this up. It's the integral from 1 to 5 of g of x dx, which is negative 2, plus the integral from 1 to 5 of 5 So the integral from -1 to 5 of g of x dx is definitely -2. They gave us that. How do I do an integral for a constant? What? You're close. It's not 25 though. It is 20. Why is it going to be 20? How do you get that? It started at 1 instead of 0. So you're doing 5, because that would be like the height of the rectangle, which is the horizontal line, times 5 minus 1. So you got -2 plus 20. And so we get 18. For that one. So whenever you have a constant, you're taking that constant and you're multiplying it by the length of the interval, because the length is going to be like your width of that rectangle, and then the constant is your height. What would we get for number 6? No. This constant is different than the constant in number 5.
Oh, that's the one that goes on the outside.
This constant is multiplied, so we can pull it on the outside right here, which means we'll really just have 3 times the integral from -5 to 5, which was 6. So 18 is the correct answer here. You're just doing 3 times that integral, which is 6, and that'll be 18. If it was a 3 alone, 30 would be the correct answer. But with the g of x, you're like pulling that out. Okay? All right, let's look at a few of these that they like to give us, like the AP exam might give you. So it tells us the graph of the function f on the interval from -4 to 7 consists of 3 line segments and 2 semicircles, as shown in the figure above. It wants to know the value of the interval from -4 to 7 of f of x dx. So that is the area between the curve and the x-axis from -4 over here to 7. Right? So we did this yesterday. We are looking at the area between the curve. All of this right here will be positive. But this stuff over here, this piece, and this piece right here, they're going to be negative because they're below the x-axis for that. So I would just break it into pieces here. I'd probably do this. I'd make this right here. That'd go all the way across here. Make that a rectangle. So that would be 1, 2, 3, 4, 5, 6. That's a positive 6. This is a semicircle with a radius of 2. So area of a circle is pi times the radius, which is 2, squared, which will give you 4 pi, but is 4 pi that area that we see there. It needs to be divided by 2, so we're just going to get 2 pi here. Both of those are positive because they're above the x-axis. I'm just doing area formulas. I also need this little tiny piece of the little triangle here. What's that one going to be? Half. What will we get for that semicircle here? It's going to have a pi. It's pi over 2. Or half pi. Yep, either is fine. There. Because you'll do pi r squared, so pi times 1 squared gives you pi, but you got to cut it in half because it's only half of the circle. And what is the area of the this part right here. That should be 1. Yes, they need to be negative. Here, technically, areas are always positive. So if I'm talking about that area, it is positive. But when you start doing it as an integral, it'll be negative. So, so what I'll be doing is I'll be doing 6 plus 2 pi plus 0.5. And I'll do minus pi over 2 minus 1. And if I combine my like terms, I've got a 6.5 and negative 1. And so that will give me 5.5, which is 11 over 2. It makes me think this is probably it right here. But you'll also have the 2 pi minus pi over 2. That's going to give you 3 pi over 2. So B right here is your answer. Yes.
Is the area of a unit circle pi?
Yes. Yes.
That never clicked.
Yeah.
I saw that
I don't know that I've really ever thought about the area of the unit circle, but the area of the unit circle is pi. Yeah. Okay, let's look at what we got going on here. I know the integral from negative 1 to 3 of 2 g of x plus 4 is 22. I know that the integral from 10 to negative 1 of g of x is 12. And I'm supposed to find the integral from 3 to 10 of g of x. So let's start with this complicated stuff over here. I really need to know just like what the integral of g of x is, because over here they're only asking me about g of x. So I need to break this apart some. So this stuff would look like this. I'd have 2 integral from negative 1 to 3 of, I'm just going to do a g right here because I can't write very quickly, plus the integral from negative 1 to 3 of 4. And that's supposed to equal 22. What is the integral from negative 1 to 3 of 4?
16.
It's 16, because the length of the interval is 4, and we multiply it by that constant, which is 4, so we'll get 16 here. So we've got 2 integral from negative 1 to 3 of g, and this equals 22. And it's going to be helpful to me to know this right here. So I treat it like it's a variable, and I'm essentially just like solving a simple equation here. So I would start off by subtracting that 16 from both sides. And then that would give me that this equals 6. Then what would I need to do? Divide by 2. And so my integral from negative 1 to 3 of g of x dx would be 3. You'll notice that is not an answer choice because that's not what they were asking us for. They asked us about 3 to 10. So what would we do here? We need to flip this first of all, because this goes from 10 to -1, which is going backwards, right? We really want to think about this left to right. So the integral from -1 to 10 of g will equal -12. There. So that tells me if I do the integral from 1 to 3, -1 to 3, which is 3, plus the integral from 3 to 10 of g, which I don't know, but that's what I'm trying to find. If I add those two together, that should give me -12, which will be the value on that entire interval. What would I do here? Subtract 3, and that will give me -15, which is answer choice B. So that is your answer on that one. Okay, questions? We've got one more to look at. Hold on. Let's see. Oh, this is not all that bad, actually. Okay, so they tell us that the regions A, B, C, D, and E, I realize that's probably impossible to read on your paper and not much better here. So I will label this stuff here. Have areas respectively. So this one right here is 2. B is 14. C is 10. D is 27. And E is 4. They did not put negatives on that 2 and that 10 because it's telling you what the area is, and area is always positive. But we know by the picture, if we start integrating, that it's gonna, those values will be negative for that. Okay, so the figure above shows the graph of the continuous function f. It gives you that. 4, -11 to 7, the function g is defined by 8 plus the integral from -5 to x of f of t dt. The first question says, is there a value of x such that g of x equals 0 for this? So, this doesn't look like it from the beginning. You know what, we gotta go over the response question. I don't think I have time to do this. We might look at this at the beginning. We might do this for a warm-up tomorrow. Well, we won't do a warm-up today. We might do it for a warm-up sometime though, because we will not have time to go over FOQ without it. So I'm gonna stop on that. The assignment that goes with this is page 313, 37 through 46, 49, and 50.